Yeah, good afternoon, everybody, and you're welcome to the second session of our three weeks webinar series organized by CIFAG. So for today, I'll be the host. I'm Kudrat Lawal. I'm also the founder of CIFAG, and today we'll be having Mr. Meshach. We'll be talking about modeling as it relates to ecosystem. Yeah, ecosystem. So briefly, let's have Meshach. You already know me now, so let's know our guest. We'll be starting his presentation in like few minutes. But before then, I want to ensure he can share his slide with us. Yeah, thank you for joining. Okay, I've changed host. Okay, good.
Can you see my slide? You can see my screen, right?
Yeah, we can, but it's not showing the presentation
Okay.
yet. Okay, good.
Yeah. But okay, you are seeing this part of the presentation, not the how do I put it now?
We can see
You are
up,
not
we
seeing
can
the
see both,
main.
but we should be seeing the crop modeling slide alone.
Yeah.
So if you
Okay.
have any question as we go on, please put
All
in the
right.
comment section. Yeah.
Okay. Yeah. So you can see the crop modeling now. Is that what you are
Yes.
seeing? Okay. Cool. Hmm. Hi everyone. My name is Meshach, and Uh, I'm a data scientist and a PhD fellow working at Landcraft at Aarhus University, which is okay. This is my real face. All right. So, which is a research center that is working on sustainable agriculture. That is, we are working on how we reduce the impact of cropping systems and agriculture in general on the environment. So that is what we do mainly. And my work in that part is to see how do we use artificial intelligence to enable the process? How do we use artificial intelligence to help model crops? How do we use artificial intelligence to model environmental systems and make recommendations that is better and more like that. So I say like by day, I'm a data scientist, and by night, I'm a mind transformation coach, and I'm an entrepreneur on weekends. So, and husband and father every day. So every time, basically. So depending on the part of me that is required, I give as needed. So today we are talking about crop modeling, and the first thing that we need to look at is how do we model crops? How do we model crops? So I mean, how do crop grows rather? How do crops grow? And we see like in terms of normal categorizations, we can see that there are about five stages of crop growth, whether it is forests or regular crop that we have. The only thing that makes it different from how a tree grows and how a regular crop grows is time that it takes. So, for example, the growing period of a regular crop may be maximum of 250 days, depending on the kind of crop, especially if it is a winter crop. And if it's a spring crop, you'll be having about 100 to 150 days in the spring season that we have. But for example, if we have people here, for people that are from Nigeria, for example, in Nigeria, we don't really have winter, spring, because we're in the tropics. So in a place like Nigeria, you have rainy season and dry season. So, and that is beneficial because it gives us the opportunity to have maybe multiple planting periods in a year, to plant different kind of crops. So that's something good about Nigeria. Like people will say that Nigeria is a very blessed country. So that's another thing then. So back to what I was saying. So about the fibrous, you have the seed, the germination, the seedling, the vegetative state, and the fruiting stage. And from the illustration that I designed here, you can see that in the seed stage, that is when you plant the seed into the soil, then the seed will begin to germinate. And one thing you see is that the shoots begin to grow upward in looking for light. All right. Then you go into the seedling stage. And the seedling stage is when instead of the shoot, you begin to see some leaves. So that will help the photosynthesis to take place. So the reason, for example, in the forest, the reason we always do this part of forestry, for example, in the nursery, is because in the nursery we can control the environment. We can control the nature, especially when the nursery is like a greenhouse. We can control the water application so that the seed, because for tree seedlings to grow, they don't follow the same time dynamics like maize. You understand what I'm saying? So because they take that more time, so that's why we do them in the nursery so that we can take care of them with focus compared to just planting something there outside. So when we do maybe a forestation project, we always go with seedlings. We don't go with seeds. If you notice the project, so we don't go to the streets to say we want to do tree planting and we are planting the seeds there. We always go with the seedlings because if we go to plant the seeds there, it will probably die. All right, because you can't manage it. So that is the use of the nursery. So you have that stage where you have the seedling. This is where a lot of time we plant our forest, and the vegetative state, which is just growing more leaves and all. And you begin to have the fruiting stage, depending on the kind of crop. You begin to have the fruiting stage, and which usually is the goal of many people, all right, the fruit. But as an environmental scientist, we don't just look at the fruits alone, we look at the whole biomass. So we always care about the total biomass of the crop. Because if you take out the fruit, the remaining part of the biomass can become residue to enrich the soil and improve the soil organic matter content of the soil. Now, when you look at all this process that crop goes through to grow, these are the things that we now then bring into mathematical equations. Then we use computers to explore those mathematical equations and apply them. So that is simply what we do in modeling. So modeling is simply taking a physical process, building a mathematical equation to represent that process. Then we use computer codes to then apply those mathematical equations so that we can derive our result. So that in summary is modeling. So and we can do this with crop model, we have forest models, we have grassland models, we have a lot of models. Almost every phenomenon, our cars that we drive, they have to first of all build a model to simulate the car operation. Your phone, they need to first build a model to simulate the process of, oh, phone call, clicking a button. They first build a model, which some people may call prototype, to represent that reality and represent that reality in the model. They can then know, okay, what should we change? What should we do better? What should we replace and every of those things before they now build the final thing. So we model so that farmers, policymakers can then know what to do physically, what recommendation to make to their farmers physically. So that is, I've explored this part of the crop modeling, which is a mathematical representation of how plant grows when it comes to crop. That's just it. A mathematical representation of how crop grows. If it's a forest model, a mathematical representation of what happens in the forest. So basically, you can build different models for different things. So it uses equation to simulate the daily life of crops from sowing to harvest by combining three main things, or we can categorize the weather, the soil, and management. These are the things that affect the growth of crop: the weather, the soil, and the management. So the reason apples are expensive in Nigeria, for example, and apples are cheaper in Denmark is because in Nigeria, our soil and climate cannot directly support the growth of apple without probably genetically modifying the apple seed to be able to respond well to the climate and soil of Nigeria. So if you see apples grown in Nigeria, especially for example, if you see apples grown in the southwest, they've probably genetically modified the seed. Okay, so so that it will adapt to the weather and climate, the weather and soil of the Nigeria ecosystem. So that is the difference. So the difference in the location, the weather and the soil of a place is what really tells the difference in the place. And that is a huge determinant of what can grow in that place because the soil is what contains the microorganism, the microbial activity that will take place to make that crop grow. All right. So there's a lot of details in that in terms of energy transfer, how the a specific microbe will get energy and transfer it, and then move from different decomposition stage to nitrification stage to the nitrification stage, and all those like seemingly complex things. So that is what happens in crop model. So we represent this in mathematical equations, and that's what I do basically for a living. So you have to know some maths, at least, some mathematics, statistics, and programming. So I program in Python, and a lot of people program in C sharp, a little of C++. Then mathematics is very important, understanding maybe differential equations, integration, and all these things. But it is not difficult to get started. When you start, you will know what to learn as you go. So don't be afraid. Maybe you want to venture into this and you're scared. So just give me a minute. I need to turn down the heating system. It's kind of too hot now.
So if you have questions or comments, let us have that in the chat box.
Yeah, back now. So, all right. So you have the input. So weather, soil, and management. And the management could be anything. The management is fertilizer application. The management is planting date, harvest date. The management can be irrigation. The management can be tillage. It can be anything that you do on a farmland. If it is forest, for example, management with thinning operation for forest, for example, that is where you cut out the branches. It can be different kind of things. We have forest operations if you study forestry. Then the output, you will have the crop yield, you have the biomass, and you have the water usage, usually. So that is what happens. So basically, if you look at a weather forecast, you say, oh, what is the weather tomorrow? So it's just the same thing that we do in crop modeling, just the way they do weather modeling. That's what is the weather tomorrow. So we say, okay, based on this equation, based on this calibration, what will be the crop yield? For example, if we use 30 kg of fertilizer compared to if we use 80 kg of fertilizer, if we plant on clay soil instead of planting on loamy soil and other things. So moving on, why do we model crops? Number one is food security because we need to know how to crop differently for us to achieve food security. Like what I always say, that there's a huge gap in agriculture, and it is the yield gap. And in a place like Nigeria, for example, because I can see that we have people from Nigeria on this call, in a place like Nigeria, we have a yield gap problem. That is, we don't have enough farmers in Nigeria. We don't have enough. We don't have enough farmers in Nigeria. Now, there's now a market problem that is an harvest issue. So the few farmers we have, they still have post-harvest losses. So, for example, if you are a tomato farmer, there's a high chance that you always lose 40% of your harvest. Like the chance is very high. And that's probably conservative. So to achieve food security, we need more farmers, but we don't just need more farmers. We need more farmers that will do things correctly. So that is why we model. If Obasanjo during Operation Feed the Nation had hired crop modelers, Operation Feed the Nation would not have been a massive failure that it became. Why? They just gave farmers fertilizers, they gave them farmland, and they put tractor, cut the everything, and just plant. And they planted, and for 3, 4 years, they were having good crop yield. Then by the fifth, sixth, 7 years, the soil organic matter started declining. Why? Because they didn't model the process for the farmers. They didn't take the weather of Nigeria, the soil of Nigeria, and have some management principle of how farming is practiced in Nigeria, and model the process and be able to tell farmers, if you are a part of this program, even though you have fertilizers, you should not use more than 120 kg on your farm. Else, you will destroy your soil over the years. All right. If you use tractors to clear your farmland, you might remove the top layer of the soil that your crop needs to grow. All these things are very important, and that is what we model. It helps us to know what should we do. So we don't just need more farmers, we need more farmers that are well informed to know the right thing to do on their farmland so that they can have high yield and reduce the environmental impact on the environment. So another one is climate impact. There's so much climatic impact of agriculture on the environment, especially fertilizer consumption. every activity you carry out destroys the environment. So we model to know, okay, what are the best practices that will reduce the impact of agriculture on climate? Then the twist is there's also a climatic impact on agriculture. Look at it. There's an impact of agriculture on the climate, and there's a climatic impact on agriculture. And that is why we don't joke with climate change issues, even though there's a president in the world that I won't mention that doesn't understand this. Okay? So now that's why we don't joke with it, because there's an impact. For example, if there's increased drought, you wouldn't have the same crop yield like you used to. Even if rainfall increase too much, if you have too much rainfall, too much of everything is bad. If you have too much rainfall, you experience flooding. And the only crop you can grow well when there's flooding is, for example, rice. Because rice paddies, of course, they need a lot of moisture like that. But when there's increased flooding, you won't be able to grow your maize correctly. So you need to look at all this extreme climate and begin to see how do we really plan. So we model all these things and say, okay, if we have long-term drought, what should we do? How much irrigation should we do on our farmland? So we write mathematical equations and computer programs that will simulate that drought process and see, okay, if we do it this way, we can still have high crop yield. Then better management to test different fertilizer, irrigation, sowing dates without losing a season. Then research insight, which is where I spend most of my time as a researcher. I work on it, do the programs and everything, and write research papers and then publish for people to benefit from what I've published. And then policymakers can then use what I've done. And companies also, they collaborate with researchers to know what is the right thing to do on their fields. Okay. And there are two ways to model crops. Number one, you have like the statistical models and you have the mechanistic models. And these are the two separate things. Number one is in the statistical model, just like if you use machine learning only to model crops, that's like a statistical model. It's an advanced statistical model. But the challenge is when you do that, you won't be able to explain why your model is behaving the way it's behaving, because machine learning on its own is a black box. All right. And what it does a lot of times is to check the association of things, then use gradient descent to optimize the parameters, and then tell you, okay, this should be the output based on the training data. And that is limited. So then when you have mechanistic model, which is what I'm going to introduce to us, they simulate the underlying biology and physics. So scientifically, we've been able to know, okay, when I plant my crop, it will stay the number of days in the soil. So let me use winter wheat, for example. If you plant in winter, that is during the cold period, maybe you plant around September, October, right? The what they call the vernalization period, that cold season that the plant will spend in the soil. So we know the plant will spend this number of days, and within this number of days, this is the microbial activity that will happen in the soil. So each of those processes, we model them, and we have modules for them that will then get to the final result. So models will model like photosynthesis, water nutrients, so that this same model can work in new climate and soil, so long you calibrate it correctly. And of course, we always need more input for our calibration at the same time. But what is more important is that we can explain why there's a change in our crop yield. And that's okay, that message is not for me. And that is one of the benefits of a crop model. So how does a process-based model work? A process-based crop model, how does it work? Number one, it will read the input. Let's say it wants to predict crop yield. It will read the input. Okay, what is the weather today? What is the soil state today? What did the farmer do today? Then you have photosynthesis, there will be allocation, soil and water simulation, then the advanced day. Then to follow this process to then know what happened on that farmland or on that field, then to be able to tell you what the crop yield is. Then that will repeat itself from sowing date to harvest date. Just like what will happen physically if I go to plant, what will happen in the soil, what will happen with sunlight, what will happen with wind, and every of those things. So the model we use, for example, at my research center is called Landscape DNDC, and it's one of the best crop models in the world. One of the best crop models in the world. So you have different crop models, but this is one of the best. Not because this is what I use, but I'm biased towards it because it is really good. Okay, so if you want to learn crop modeling, maybe you need to learn landscape DNDC. Okay, so it is built by KIT and Aarhus University, where I work. And what it does is simulate carbon, nitrogen, and water fluxes. And these are the cycles that happens in the soil and in the environment for crop growth to happen. There's carbon exchange, carbon distribution, there's nitrogen process that takes place from nitrification to denitrification, and there's water fluxes, that is the hydrology. How water moves from one part to the other in the soil to be available to the soil, like available water, how water is available to the plant to grow, because you need all this interaction for photosynthesis to take place. Okay. And it is modular by design. I will just keep all these details. And this is an example of how the model works when it comes to, like, if you want to have a simple modeling of a wheat yield, for example. So the phenology will happen, and this is what we call the DVS. So the DVS is the metrics that help us know what is the stage of the crop. Is the crop really growing? So if the DVS is less than 1, then the crop is still growing, but the DVS cannot go more than 1. When it is 1, it is telling us, okay, this crop has gone from sowing and is now harvestable at this time. Then the photosynthesis will take place. So you need to understand the phenology, which is where am I? Phenology, the crop stage, the crop growth stage, is tracked using the growing degree days. These are more scientific, and I don't want to go into the details because of time. Then photosynthesis will happen. Then there's allocation, and in the end, there's harvest. And all these equations will follow each other for the model to be able to understand what is happening. And what you give to the model is you need to know the climate of the place, and you can download this online. Like if you go to open source climate platforms, you can easily download climate data set, like the daily temperature, the rainfall, solar radiation, humidity, the wind. All these climate metrics are important. For soil, you need to understand the soil texture. You need to know the soil texture. That is, what is the sand percentage? What is the silt percentage? What is the clay percentage? You need to you need to know the values for the bulk density, the pH, then the organic carbon content, the initial nitrogen pool of that site. Then for the management, you need to know the planting and harvest dates of that crop. If it is a spring crop, you need to know that, of course, I can't plant a spring crop in September because that is not spring season. Okay, you need to know what is the planting date and when should it be harvested. If you put the wrong date, you will get the wrong result. Okay, then crop species. What is the crop? Because the way we model maize is not the same parameter set that we use to model wheat. It is not the same parameter set because they are different crops and their crop phenology and physiology is different. All right. Then fertilizer amount, for example, when should you apply fertilizer? What is the amount of fertilizer to be added? And tillage operation that you carry out on the field. Should you do tillage? Should you do irrigation? And all those things. So you need to have all those information and present them in a specific file. It can be in an Excel file, and we use a translator to translate the information from the Excel file into the structure that the model can understand, which is the extended markup language, which they call XML, that will feed into the model. And these are the outputs that you get and the SI units. So you get the grain yield in kilogram per hectare, the above ground biomass in tons per hectare, the leaf area index, the water use, the nitrogen uptake and leaching, the soil carbon storage, and there's a lot of results that you can get. But this is just a summary that we have. And let's say you simulate a maize season, for example. In the end, when you plot your result, you will have a result like this. You can see let's say I plant maize in April and I'm harvesting in October. So in Nigeria, another thing that we are lucky for is that if you plant maize in Nigeria, you don't need to stay so long to harvest it compared to what they experience in the temperate region, right? And other places. If they plant maize, I was surprised when I was seeing that maize was taking 6 months and I'm like, wow, Nigeria is so blessed. Have you seen people in Nigeria, even in FUTA, then when we do CSP, we don't even use 6 months in a semester to plant maize and it gets to the harvestable stage. And that's like, wow. So there's something good if we tap into it as a nation. So for here now, you plant it in April and you can just see how the biomass begins to increase. If you look at the plots, how the biomass begins to increase. So you will see that usually there's like a slow start. All right, there's like a slow start. There's like a slow start. So it will start slowly, then it gets to a point where there will be a rapid uptake, then it will get to a point where you have the grain filling. And the grain filling is when the carbon begins to shift into the different crops, into different parts of the crop. And there are strengths and limitations, of course, to any kind of model. There are strengths and limitations, and that has been detailed here. The strength, but the limitation is that sometimes, of course, you need to know how to code. The calibration may take time. Sometimes you're on it for like 25 days to ensure that this model works perfectly and different other things. So I think that is the summary of what I want to show us. I wanted to demonstrate the model for us in 1 or 2 minutes. I believe I can still do that. A quick demonstration.
Yeah, you can do that. So, guys, the
Okay.
quiz questions is now in the chat box, please, in case we go off
Oh,
anytime. So you can share that. Thank you.
okay. Yeah.
So please
Thank
send the
you.
quiz response to as reply to that email you got earlier. So I'll see you next week.
Okay.
Yeah.
All right. So you see the a quick demonstration of the model now. You can see this part of my screen, right? Where I have this code.
Yes, but you can zoom
All
in a little
right.
bit.
Okay, I will zoom in when I can. Okay. Can you see this? All
Yes.
right. Okay. So we just see a quick demonstration of the model in action. All right. So this has opened the VS Code. This will have the files. And in the files, you can see the different files that we have. The air chemistry, all these are like climate parameters. We have the climate value, precipitation, temperature, radiation, and wind values. These are the management file, this which is what I want us to see. And let me zoom this out. All right, so this is an example. For this, I'm telling it, do tillage in this year, in these dates, and in this month. The depth of the tillage is 20 centimeter. Do planting, all right? And the crop I'm planting is winter wheat on this date. So I'm giving that instruction to the model. So when I run the model, which is what I'm going to do here, I just say DGBZ, and I'll copy the path and run the model so that you can see. I say CD to the path, and I say SH DEGBZ dot SH. So I have all the code written before. So then when I click it, so you see how the model runs. You see it's running and it gets to 100. So this is just one field. So it doesn't take much time for you to see the output. And I have the output here. And for the output, you can explore each of the output that you get. You can see the fertilizer report, harvest report, the manure report, soil chemistry, yearly, and physiology, microclimate. So in the report harvest, you will see the crop yield and all other information that you need for your biomass estimation. So you can see this, okay. You can see this is fruit export. So these are some values of the crop yield that you have in kilogram carbon per hectare. And if you have like a lot of time, you can explore this further. But I just wanted to demonstrate, for example, how this model runs and the output that it gives. So I'm pressed for time, so I can't go very deep into the explanation. But I hope you learned something at least. Yeah. Thank you very much.
Yeah, thank you so much, Meshach. That was detailed from the little information, from the simplest information to how we can actually run that. So I was even thinking, I visited a research center in Bangkok, can you hear me? Where they had, I don't
I can
know,
hear you.
okay, they have
I can hear.
all types of forest. I mean, it's like a practical. They have some plastic presentation and all for tropical forest, for temperate, and for the boreal forest. So I was thinking of, is it possible to plant pine, spruce, and all these forest trees in Nigeria? What do you think is possible? Maybe for
Yeah,
education purpose, like they did
yeah,
exactly. Yeah.
yeah. Of course, you can have like, for example, a greenhouse, a control. They call it a microclimate. You can design a microclimate and look at, okay, what are the climatic parameters or the ranges that pine needs to grow. Then you can do that as a lab experiment and control the climate. You can control humidity, the precipitation within that microclimate. and you can grow it there. But if you want to do it on a large scale, that will most likely be impossible because you can't design a microclimate that will be that big without spending billions, of naira. So
Yeah, true.
what people mostly do is to genetically modify seeds so that the seeds can perform well with that climate. And that is the work of some biotechnologists. It is above my pay grade.
Mm. It's
Yeah,
interesting actually. So any
yeah.
question from anyone? You still have few minutes. Yeah, that's a minute. Any question? Beauty? Are people in food? I mean, any question? Thank you so much, Meshach. So
Thank
I
you.
think we have a question here. Aisha Bashir. I don't know. Maybe she just muted her mic. So I'll see you next week. Please ensure you send the quiz response via email so that you can get the access link for the next session. So we have few people now. We had about 100 registered emails earlier, and now we have approximately 20. Yeah, expected. So thank you, Meshach, once again. Yeah, till next
Thank
time,
you very
guys.
much.
All right.
Yeah, thank you.
Bye.
Bye.
Bye.